We're going to take a look at some piecewise functions. A piecewise function is a function that is defined in pieces. The first thing we're going to do is look at the domain and range of a piecewise function. The domain will be the x values for our piecewise function, and the range will be the y values for our function. It's also important to remember that we'll be writing our answer in interval notation, so our open and closed circles on our graph are going to be important. It's important to remember that if there's an open circle on the graph, that means that that number is not included, and in interval notation, it will result in parentheses. If there's a closed circle on our graph, that will tell us that the value is included and will result in brackets. Let's look at an example. First, I want to look at the domain, and domain is the x values. So what I want you to do is think about taking these values to the x-axis. So we would have an open circle there. And then if we come down here, we have another open circle and all those values in between. Then here for this next part, we would have an open circle at 2, an open circle at 3, and we connect those values. Now, if we just look at the x-axis, our domain would be from -4 to 0, I'm using parentheses because those are open circles, union 2 to 3. Next, let's look at y values. The range is y values, so we're going to look at taking our graph over to the y-axis. So here we would have an open circle at -3. We already have an open circle at 5, and we include all of that. Since this other guy over here off by himself would result in open circles there, but we already have the values on the line that close it, we don't need those values. So our range, we always go from least to greatest, so we're going to go from down to up, would be -3 to 5. Again, parentheses because those are open circles. Let's look at the next one. We'll start with domain, and again, domain is x values, so we're just going to look at the x-axis. We'll take this guy up, and he's a closed circle at -4, and we have a closed circle at -3, and the whole line in between. And then over here, we have an open circle at 1, an open circle at 2, and the piece in between. So to write the domain, going from left to right, we have a bracket because it's a closed circle, -4 to -3, union 1 to 2. Let's look at the range. Our range is the y values, so we're going to bring our value all the way over here. I have a closed circle at -5 and a closed circle at -3 and all of the values in between. Again, just like the one we did a second ago, these guys would come over here as open circles, but those values are already included in our other piece of our graph. So to write our range, we will go from least to greatest, so down to up. We would have a bracket, -5 to 0. Let's look at another one. Starting with domain, again, domain is x values. So coming up to the x-axis, I have an open circle at -1 and an open circle at -5, and they're connected. Looking at the second piece here, I have an open circle at 3 and an open circle at 5, and they're connected. So my domain would be -1 to 0, union 3 to 5. Next, let's look at range. For the range, we're looking at the y values. So we have an open circle at -5 and an open circle at -4, and they're connected. And then following our other graph there on the right, we would have an open circle at -2 and an open circle at +2, and all those pieces in between. Again, remember, we're just kind of dragging this point over to the y-axis to see what happens. So my range, going from least to greatest, would be -5 to -4, union -3 to 2. Last one. Here, starting with domain, we have an open circle at -3 and open circle at 4, and everything included. If we bring this guy up, he's now a closed circle. And then bringing this last guy up is also a closed circle and the line in between. So for this, my domain would be -3 all the way to 5, and the 5 has a bracket because it's included over here. We don't need to stop it at 4 because this closed circle right here closed it, right? It was open before, but that closed circle closed it. If that had been an open circle, let's talk about that for a second. What if that had been an open circle down here at the bottom? So starting again, we would have the open circle at -3 and the open circle at 4. And then this coming up, I didn't draw that very well. This coming up would come up as an open circle, and then we would have the closed circle at 5, and we would still have that whole line. So this would change because now we would have -3 to 4 with an open circle, and then 4 to 5 with the closed circle, to the closed circle, which gives us the bracket. We can't include the 4 because the open circle means that the 4 is not included. Now let's look at the range for this one. For the range, again, we're looking at the y values. So we would have a closed circle at -5 and a closed circle at -4. Again, remember, we're just kind of bringing those points over to the line, over to the y-axis. And then here, open circle at -1, and this guy, open circle at 0. And we're connecting those and connecting those, right? We have that whole line. So our range, least to greatest, would be -5 to -4, both with brackets, union -1 to 0, both with parentheses. So if every time you'll think about taking the values for domain to the x-axis and the values for range to the y-axis, I think it'll be a little bit easier. Next, I'd like to look at graphing piecewise functions. So for a piecewise function, we may have a break in our graph. It just depends. We're going to start by looking at the first piece, and I'm just going to kind of draw some green there because that's the color we're going to use. If x is less than 2, then we're using x minus 4. We know that's the equation of a line, or you can graph it using points if you need to. Plug in a 2 first because that's where the boundary is. So 2 minus 4 gives me -2. So at 2, I have a -2, and that's an open circle because that's a less than. Now, I know that this line would be the line y equals x minus 4. So it has a y-intercept of -4 and a slope of 1. I'm just going in the opposite direction there. Pretend that's a straight line. So that's when x is less than 2. Now let's look at what happens when x is greater than 2. I'm going to do this one in blue. If x is bigger than or equal to 2. So we need to really concentrate on what happens at 2. So at 2, if I plug in my value there, I would have a -4 plus 2, which is -2. So I have 2, -2, but this time it's a closed circle. Right? A closed circle. And then I know that that is y equals -2x plus 2. So that's what's going to happen to the right of 2. It has a slope of -2, so down 2 over 1. So that would be that graph. In both cases, notice that what we did was we figured out what was happening at the boundary, and then we used our slope to figure out the rest. Here, again, we have a boundary of 2. Our first one at 2, let's see, if x is 2, we would have -5 times 2 plus 3, so -10 plus 3, so -7. That gives me the ordered pair 2, -7. It's less than or equal to, so that's going to be a solid circle. At 2, -7, I have a closed circle. My slope is -5, and we need the graph that's going less than -2. So for a slope of -5, we would go either down 5, right 1, or up 5, left 1. So here would be my line there. And then for the next piece, if x is 2, we would have 2 minus 4, which is -2. So I'm going to have the ordered pair 2, -2, but it's going to have the open circle. So there's 2, -2. And then my slope is 1, so up 1 over 1. Okay. I'd like to look at 2 more with you. Here's the first one. Now notice our boundary is at -1. So for our first guy here, if x is -1, we get -1 plus 3, which is 1 plus 3, which is 4. So that's the ordered pair, -1, 4. And that's less than, so we have an open circle at -1, 4. The slope of this line is a -1, but we want to go to the left because this is less than -1. For a negative slope, we would usually go down 1, right 1, or we can go up 1, left 1. So here is the first part. For the second part, we're again going to check x equals -1, but in the other equation, so -3 times -1 plus 1 is 3 plus 1, which is 4. That's -1, 4, but because it's greater than or equal to, we're going to close that circle up. And then my slope is -3, so that's down 3, right 1. One more. Doing the same thing, my boundary is at 1. So looking at the first equation, if x equals 1, I have 5 times 1 minus 4, which is 5 minus 4, so 1, giving me the ordered pair 1, 1. Notice that's less than or equal to, so I'm going to have a closed circle at the ordered pair 1, 1. Now I'm going to pay attention to the slope, which is 5. Usually for 5, I would go up 5, right 1, but I want to travel left because I'm looking at values of x that are less than 1. So I will go down 5, left 1. Oh, try to draw that better for you. There you go. And then lastly, for x equals 1 for the second part of our function, that's negative 1 plus 4, which is 3. That's going to be the ordered pair 1, 3 with an open circle because it's greater than. So 1, 3. And the slope is negative 1. That's down 1 over 1. There you go. So for each of these, you're going to want to check your boundary point and really just work with the slope there. Hope that was helpful.